Have you ever just looked at the world and wondered how it all works? You know, how a couple of simple things can mix together and create something brand new? Or how something complex can just break apart? Well, that's not magic. That's chemistry. And today, we're going to pull back the curtain on two of the most basic moves in the playbook: building up and breaking down. I mean, just look at this stuff. A tablet fizzing away in a glass of water, food cooking on a grill, the insane flash of fireworks. These are all chemical changes, happening all around us, all the time. And you know what? They might look chaotic, but they're not. They're all following a very specific set of rules, a kind of chemical instruction manual for how our world works. So that's the million-dollar question, isn't it? How can we possibly know what's going to happen when we mix stuff together? Is it just a big guessing game? No way. There's a real logic to it, and that's exactly what we're going to unlock today. And here's the secret, right here. It's all about learning to spot the patterns. Once you can see the basic blueprints for how these reactions go down, chemistry stops being about memorizing a million different facts and starts being about understanding a few simple, really elegant rules. Okay, let's start with our first major pattern. Let's call it the builder. Seriously, think of it like playing with Legos. You start with a couple of simple pieces, you click them together, and bam, you've built something bigger, something new. In chemistry, this has a name, a synthesis reaction. So the official definition is pretty simple. You take two or more starting materials, we call those reactants, and they combine to form just one single new product. The key thing to remember is that you're always ending up with one bigger thing from multiple smaller things. And this picture just nails it. You take reactant A, you add reactant B, and they fuse together to create a totally new thing, AB. It really is the most basic building block of chemistry. Two things become one, simple, powerful, and once you see it, you can't unsee it. All right, theory is great and all, but let's actually get our hands dirty and put it into practice. We're going to walk through how to predict what happens in a synthesis reaction, step by step. And we're going to make something you definitely know, regular old table salt. Here is our 6-step recipe. This is our roadmap for figuring out exactly how these chemicals are going to hook up. It's a proven method, and we're just going to follow it right down the line. Okay, first things first, our ingredients are reactants. We've got sodium, its symbol is Na, and chlorine with the symbol Cl. Now, you probably noticed the little 2 next to the chlorine. That's because chlorine is what we call diatomic. It's a bit of a social butterfly and almost never flies solo in nature. It always brings a friend. And now for the really cool trick, the crisscross method. Look at the charges here. Sodium has a +1, and chlorine has a -1. To figure out the final formula, we just swap those numbers. Forget the plus or minus sign for a second. The one from chlorine's charge goes to sodium, and the one from sodium's charge goes to chlorine. And since chemists are kind of lazy and don't write the number 1, we're just left with our final product, NaCl. And here we are at the last and maybe most important step, balancing the equation. See, there's this unbreakable rule in the universe. You can't just create or destroy stuff out of thin air. So whatever atoms you start with, you have to end with. Remember we started with 2 chlorine atoms? That means we have to end with 2. So we make 2 molecules of NaCl. But now that gives us 2 sodiums on the right. No problem. We just go back and say we needed to start with 2 sodiums on the left. And look at that, perfectly balanced. Everything's accounted for. Okay, so we've mastered the builder. Now let's meet its complete opposite, the demolisher. If synthesis is all about building things up, you can probably guess what this next one is all about. It's called decomposition. And yeah, the definition is exactly what you'd think. It's a reaction where one single, complex thing breaks down into 2 or more simpler things. You start with one, you end up with many. Easy. And the formula? It's a perfect mirror image of what we just learned. We start with the compound AB, and it just splits apart into its pieces, A and B. One thing becomes 2. It's the same logic, just running in reverse. All right, time to put the demolisher to the test. And for this one, we're going to take a compound we all know and love, water, and we're going to predict exactly what happens when you break it down into its core pieces. And hey, this process should look super familiar. We're following a similar roadmap, only this time our goal is to see what a single compound shatters into. It's the same kind of thinking, just for taking things apart instead of putting them together. So we're starting with just one reactant this time, water.
H2O. And when we apply some energy, we know it's going to break apart into what it's made of, hydrogen and oxygen. So those are going to be our products. Makes sense, right?
But wait, here's that crucial little rule again. Just like chlorine, both hydrogen and oxygen are diatomic. They hate being alone. So when they break off from that water molecule, we don't just write H and O. We have to write them how they exist in the wild. H2 and O2. It's a super important detail to get this right.
And finally, we balance the books. To get those 2 oxygen atoms on the right, we must have started with 2 water molecules on the left. Okay, but that gives us 4 hydrogen atoms on the left side. No sweat. We just make sure we end up with 2 molecules of H2 on the right. And there we have it, a perfectly balanced decomposition. Nothing created, nothing destroyed.
So let's just put it all together in one spot. Synthesis is our builder. A plus B gives you AB. You start with 2 or more things, you get 1 thing. Decomposition is our demolisher. AB breaks down into A plus B. You start with 1 thing, you get 2 or more things. They're perfect opposites, just 2 sides of the same chemical coin.
And this is really the whole point. What you've learned today isn't just a couple of random equations. You've learned how to recognize 2 of the most fundamental patterns in the entire universe. This is a skill, not just a fact. You now know how to spot the builder and the demolisher out there in the real world.
So we've seen how things can combine and how they can break apart. But that's not the whole story. What happens when 2 compounds meet and instead of building or breaking, they just decide to swap partners? Well, that's a whole other dance and a story for another time.